Hello everyone. So today in this tutorial I wanted to cover the complete VSAM in 1 hour or maybe in less than 1 hour. I wanted to cover everything related to the VSAM. Okay. So with that said, let's get started. So what exactly the VSAM stands for? VSAM stands for Virtual Storage Access Method. So unlike a flat file, we have a VSAM file. So in the flat file, so there are certain operations that you can do, like storing the data either in a fixed block, fixed file, or in a variable record format, and you can store n number of records within that particular data set. So whereas VSAM, why we use VSAM is VSAM files are very much secured, and it can be used in both batch programs and in online programs. So when I say batch, it is related to the cobol programs. When I say online, it is related to cics program. Once you create this VSAM file, you can access using the cobol batch programs, and you can access using online cics programs. So here we call VSAM files as a cluster. A cluster contains data component, index component, and named component. Altogether, this is called as a cluster. So when I say data components, the data component is nothing but where the actual data is stored, and the index component where the index is stored. So depends on this. There we have different kinds of VSAM data sets that we work in real time. So one is KSDS dataset, ESDS dataset, and RRDS dataset. I can say the VSAM files. When I say KSDS, it's a key sequential dataset, and ESDS is nothing but it's a entry sequential dataset, and RRDS is called as a relative record. When we say KSDS, I am saying it as a indexed, right? So here, when you are writing in a cobol program, you will be using equivalent indexed. Organization is indexed in the cobol program. When you are using an ESDS sequential file, you will be using organization is sequential file, and when you're using RRDS, you will be using organization is relative file. So that means the name itself indicates that indexed means it is storing some key there, and ESDS means it's storing a sequential. You are pulling the information in a sequential order. RRDS, if you want to retrieve the information in a random, then you will be using RRDS. So okay, the name component, it has a name component, data component, and index component. Okay, so with that said, let's go ahead and create a sample. Let's connect to the mainframe and create a KSDS file. Okay, okay, yeah. So what is a utility that we use to create a VSAM file? So we use an IDCAMS utility to create a VSAM file. So let's look at the properties that we pass on to this utility IDCAMS program. So first thing is define cluster, and you'll be specifying the cluster name. Okay, here we call it as a cluster. And the record size, you can mention it as 80 or 80. So 80, this is an average length of the control data sets, and this is the maximum length that a record can handle. So average I'm giving 80, and the maximum length also, and I'm giving it as an 80. So it can store a fixed byte information and a variable byte information as well. Cylinders is a space, free space is something that we'll discuss, and the keys. So since this is an indexed format, so we use indexed word, index keyword, volume is something volume, control interval size. So here the data is stored in the form of a control area and control interval. So why? Because it has two things. One is a data component and index component. So index component is the one where all the indexes are stored. That means it's like a key. So for example, let me take a book. So book quick reference will be there in the index. Based on the index, you will be going to specific page or specific chapter, right? So in the same way, we have a index component separately stored and a data component separately stored. So in index component, all the keys are stored, and in the data component, the original data is being stored. Okay. So for that, the data, when we have a data, so the data will hold some control area, and within that control interval will be there. So within the control interval, so you have a logical record stored there, and beside to the logical records, you have something called as a record identifier, RIDF, and you have some free space. So that's where in the internal memory you will be seeing a free space, and then you will be having a control interval free space. So this is the structure they have, internal structure they have while within the VSAM file. So what to remember? So define the cluster name, record size, keys, control interval size, but it's a maximum this is a 4096. So that is, and another key thing that you need to remember is indexed. So based on this, we can create a cluster. So let me change this to customer.ksds. Okay, yeah, let me change this to customer.ksds. Okay, yeah. And another thing, why do we need this? VSAM file, right? So as I said, so in order to store large volume of a data and you wanted to maintain some master data, for example, if you're working in a banking project where all the customer information will be stored here, like customer name, address, phone number, and so on, right? So in a bank, if you have 1 million customers, all the 1 million customers data I wanted to store into the database. So that's where VSAM files will come into the picture, right? So they can refer that particular data at any point of time, either from the batch program or either from the cobol program or from a VSAM file. Okay, now with that said, let me submit this and see what happens. Okay, this JCL is submitted. Okay, so it throws an error. Why? Okay, no, so I have different things created, so that's the reason it is throwing an error. Okay. So with that submission, so it will create this. So now you can see you have a data component and you have an index component and you have a cluster created, right? So now with the same IDCAMS utility, so what I wanted to do here is okay, now for example, someone has told you like, okay, this is a VSAM file, but you don't know what are the properties, what is the record length of it, or what is the key size of it. So then how do you how you can know about that? That's where the LISTCAT comes into the picture. So in the LISTCAT, so what you can do is just take the cluster name. Okay, so when I say cluster name, just search for this volume VSAM. Okay, so then specify here. Okay, so you'll be again using the same IDCAMS utility to see the properties. Just specify LISTCAT entries and cluster name and then submit. It ended with 0, so then you can go to spool and see the properties in the sysprint. Now you can see the properties of the VSAM file. So when it is created and what are the associations it has, like data component, index component, and where is the data stored, creation date, expiration date. You can see average record length is 80 and maximum record length is 80, and the key length is 4, right? So that's how we have seen splits, control interval, control area. I was just talking about that, right? Free space for control area 20 and 10 for free space, cylinders. So all these properties information that you can see here within this. So you can see other properties. The number of entries processed was So you can see the data component is 1, cluster is 1, and the index is 1. So the total you have 3. Okay, the number of protected entries suppressed was 0. So okay, so that's how we can see the properties of a VSAM file. So when you want to see the properties of a PS file, so how you used to see, just type as beside that, and you used to see the properties, whether it's a sequential file or a fixed block file and so on, right? So that's how you used to see it. Okay, so now what is the next thing that we can do with this? So you have got the dataset created, VSAM file created, and you know how to see the properties of the VSAM file. Now let's copy some data to this VSAM file. Okay, so now what is the command that we use? We use REPRO. REPRO is the command that we use to copy the data. So KSDS dot cluster. Okay, so here again we'll be using IDCAMS utility to copy the data from input dataset to output dataset. Okay, and so what is the customer information that we have here? Let's go ahead and see what is that we have. So okay, now you can see there is a 4 bytes of key is there, so make sure like these are in a sequential order, and this is sorted already before copying to the KSDS file. You have a name, state, city, city, state, and zip code. Just I wanted to copy all these records, so you have to give this and then submit. So it ended with 0 0, right? So when you go to spool and verify what it has done, sorry, here it will be here. So you can see that number of records processed was 14. So that means 14 records that were there in the flat file PS file are now copied to the VSAM file. So now you in order to browse the flat file, so what you used to do, so just if you just customer.info, okay, if you just browse you will be able to see it, whereas for the VSAM file it will not allow. So in order to do, what you need to do is, so you need to have another IDCAMS command, so where you can print KSDS dot cluster. Okay, so now you have another IDCAMS, so where you will be passing the commands called as print in file and this, so that when you submit this, so you can see the data in the output file. Okay, sysprint. So now you can see all the information is displayed. So as I said, key of record, so one is an index component and other is a data component, right? So from the index it stored, in the index it stored 1001, and the data it stored the actual data of this in the same way. You can see it is in an ascending order and it is stored the values, right? So this is how we can copy the data. We can print the data which is there in the VSAM file. And another one, what you can do is, so initially now you have copied the data from flat file to VSAM file. Now reverse, so if you want to copy the data from a VSAM file to a flat file, so what to do, right? So that's the another important thing that we need to know, right? So here what you can do is you can do a repro command, in file dd1, that is a flat file, and out file dd2, that is the unload file, right? So that's how you can do, so that whatever the data that you have you can copy. And you also need to specify the key, from which key to which key you wanted to copy. So 1001 to 1010 I wanted to copy, and first check whether this file is already created or not. Let me close this and unload. Okay, this is already there, so deleting. I have deleted that, and step 100, right? So instead of running the first step, I will just restart equal to step 100. Okay, then submit. What is that? Step 100 only, right? Yes. Oh, there is a typo here. Okay, now submit. It ended with 0, then enter. Now you can see till 1010 all the records are unloaded, right? So in real time, this is how we do, I mean, this is things that we take care, like loading the data from a flat file to a VSAM file and unloading the data from VSAM file to a flat file. So this is the continuous process that we do, when especially when you're trying to debug any of the cobol program issues or anything. So then we, instead of again browsing the data set, so we can play around when you have the flat file data copied to a flat file, right? So if you are using an since we are working with the KSDS files, we use from key, and if we are working with an RRDS, we use a to address, and then to from number we will be using, and if it is a ESDS, then we use from address and to address. So that's how we use it. So now, so we have done with the repro command as well. So now if you want to delete this particular cluster, so you use a command called as delete and the cluster name, so that it will delete the entire cluster. And if you want to rename it, so you can use an alter command. So old class, I mean VSAM file name and the new VSAM file name. That way you can create a I mean rename the VSAM files. Now let's move on to the ESDS. ESDS is nothing but an entry sequential data set, and to create the ESDS VSAM also we use what we do is we take the IDCAMS utility, define cluster name and the record size, cylinder, control interval size, and here instead of indexed we will be using it as a non-indexed, whereas in that KSDS we used an index keyword, and here we'll be using a non-indexed keyword, right? So let me delete this. Okay, and let me delete this as well. Okay, and then submit. Okay, it is created. So now let's see how many components it's get created. So now you can see that it has created only two components. One is a name component and it is a data component. There is no indexed, so that's the reason. Since it is a non-index, so we are seeing only the data component, right? So there is no index. So now let's see how do we copy the data to this particular cluster, right? So again we use a REPRO command here. So REPRO command in dataset. Okay, customer dataset is already there. So now here I'll use this cluster and submit. Okay, so ended with 0. I hope this cluster will have some data, and again I'll submit it. So that means here why I have submitted 2 times is I have copied all the 14 records, and again I'm trying to copy another 14 records, so still it's allowing. So now that means I'm trying to copy the duplicates here, so but it's allowing. That means KSDS will not allow the duplicates, whereas ESDS will allow the duplicates. Why KSDS was not allowing the duplicates? Because it is a indexed one, and ESDS why it is allowing? So it is a non-indexed one, so that's the reason it is allowing. Now let us go ahead and print out what is the data that is present here, right? So how do we print it? Again we need to take the IDCAMS utility and we can print that. So I'll take this cluster here and just try to submit. Okay, and enter with 0. Okay, now let's see what happens here. Okay, now you can see the relative byte address So it is stored in the form of a relative byte address, right? So when you are using it and trying to pull this VSAM file, organization is numbered you can take in the COBOL program to retrieve this information. So now you can see all the duplicate records are being stored here, right? So you can see it is stored in the form of a byte 0, 80, 162, 40, 320 and so on. A plus 80 plus 80 it adds. If it is a 45 byte 0, 45, 90 like that, it is going to add it. So okay, so that's how we create an ESDS file, that is entry sequential data set, sorry, RRDS file. So now ESDS file. So ESDS file is created. Now similarly RRDS. So now RRDS file is created using the same IDCAMS utility. Here we don't specify any non-indexed or indexed, so here we specify numbered. So again it has two things, one is a cluster name and the data name. There is no indexed format, and when we submit this, it gets RRDS gets created and you can load the data to the similarly same like a flat file. And so what you can do here is okay, yeah, so similarly it's a similar way you can use all the repro command to copy the data, and if you want to print see the properties, you can see it. And does it allow the duplicates? No, this will not allow the duplicates. And you can store a number of records within this based on the cylinder size that you have mentioned, right? So similarly, if you want to create an LDS, so you'll be not specifying any record size there, but you specify it as linear, so that it will create a linear data set. But maximum, I never use linear data set. The data sets, the VSAM files that you have used is mostly the KSDS as the first one, then ESDS, and then RRDS. So these are the three different VSAM files that I have created, and these are the various operations that I used to create. Like using an IDCAMS utility, I used to create a VSAM file, and then I used to create use a REPRO commands to load the data and unload the data, LISTCAT to see the properties, and print to print the data set. And delete is to delete the VSAM file, and alter is to alter the VSAM file name. So that's how, guys. So these are the different things I just wanted to explain you all in this, and just wanted to cover this, right? So far we have covered IDCAMS, REPRO, LISTCAT, print, and delete, right? So this covers the complete VSAM. And if you want to know more details, I have also created a separate VSAM playlist within this YouTube. You can also watch that as well. And if you ask me a question like in COBOL program where these files are used, yes, we are using this. So if you are using an ESDS file, it should be used as an organization is sequential. If you are using a KSDS, it should be used as organization is index, and whereas for RRDS, organization is relative. And when you, how do we use this VSAM files in an online, that is CICS? So you create an entry in the FCT table, that is a file control table, where you can read this VSAM files, right? And VSAM datasets can be used to insert the data. You can insert the data, you can retrieve the data, and you can delete the data. In CICS, you are provided with the CICS screens where you can insert the data, and so that the data directly gets stored into the VSAM files. And you can also pull the information from the VSAM files using an online screen or a batch COBOL program, right? So there we use exec CICS within the exec CICS, and we write the set of codes to pull this information. Either if you are using a KSDS file, you can use set of commands to read or rewrite or delete the records using the COBOL program. and you can also traverse from forward and reverse and so on. So these are the different various activities that we do when you're working on the cobol plus VSAM and cobol plus VSAM plus cics when you are using in an online screen. So I hope guys, so this covers the complete VSAM tutorial, and we also have another concept called as a alternate index as well within the VSAM file. Okay, so this with it said, so this covers the complete quick refresher of a VSAM. I hope you like this video, so please do mention your comments or the feedback on this video, or if you would like to know much details on any topic in the mainframe, you are welcome. Just write a comment there, and if you for more and more updates, you can do subscribe to my YouTube channel. Thank you so much. Okay, now we are entering into the another important topic, that is on AIX, so which is a very advanced topic. So we olden, I can say, like it's for the older projects we were using some AIX, but most of the projects where I work, I think I have came across this AIX only once in my work life. So apart from that, I didn't come across this. So once the DB2 came, right, so after most of the projects we started using DB2, so then we have been not using this AIX. So what is AIX? AI is nothing but it's called as an alternate index. If we need other than primary key, then we define an alternate index. To define the AIX, below are the steps we need to do. So define AIX with IDCAMS, then we need to build a path, and then we have to build that. Why we have to go? So when multiple, for example, let's take a real-time example. So let's say like you are working on an insurance project. Okay, within an insurance project, you will be, if a X person with an SSN number has taken multiple policies, and I wanted to research, I wanted to look at how many policies been taken by this particular SSN number, right? So if you look into the policy table, so the policy ID will be the primary key, and when we it followed by the SSN number, right? Policy number, SSN number, policy number, and SSN number. How do I track of it each? So in that case, what we can do is we can combine SSN number and policy number combined together, so that together combination will form an AIX. Or let's take if a person is having multiple bank accounts. He's having multiple bank accounts, and each bank, so in each bank he will provide his SSN number, right? So based on SSN number only his bank account is created, right? So if I want to look at the balance, what is the balance available, total balance available for that particular customer within all the banks. Let's say like we can take a big billionaires where they may be having multiple accounts in different banks. I wanted to see what is the total balance they have. So I mean, it's like if a government is wanted to check who all have a huge money, so they will keep an eye on those accounts and they will monitor it. So in that case, so we can have an alternate index created with the tax number or SSN number and account number combination. Right, let's say, so this is the policy data that you have. So here you have a policy number and so on, name, area, state, district, and you have the policy number added here, right? So then how the code looks, AI index, first what we need to do is we need to create an AIX. So how do we create? Using an IDCAMS utility, and you need to specify the record size and the keys. And the key that you are mentioning, so it will also have the index and the data. So specifying that key is equal to 4,0, since it is a policies of 4 bytes. So that we have created the KSDS policy here, and then you have you are trying to load the data into the KSDS file. So before that, what we are trying to do is we are trying to create a KSDS file initially before creating what we can say, I'm trying to create a KSDS file, so with all this information copied. right? So first step, we need to create a KSDS file. So where I'm just forget about this part. So first I'm trying to create a KSDS file which holds the policy information, right? So step 2 is to copy the data to an KSDS file. Then after that, what we are doing, so we are trying to create an AIX. So AIX is again created using IDCAMS with name as AIX, and you have to give your AIX file name, right? Once this is done, so you need to create a path. So how do you create the path? You need to create a path by name, giving it as AIX path, and you have to map the AIX that you have given there. And then we need to copy the data that is from KSDS file to a AIX. So that means we are trying to build the index file now. So how the index file, in the sense, so we had that policy number and SSN number, right? So now in the combination of those two, the files gets created. So now since build has done, so first we have created an AIX, then we have defined a path, then we have tried to build it. Then after that we need to print the data. What do we have? So printing the data means, so whatever the policy information that was there, so that it will be printed in the AIX file. So let me connect to the mainframe and show you so how the data looks. So what we had here, MADF policy.info.ki, let's take that AIX. So this is the steps I have followed there. So let me see. So while building the AIX, just I want to show you here. So what are the two key factors? One is the name of the AIX, and to which you are relating. You are relating to policy, and you are giving all the rest of the properties in the AIX, and then you have build a path to that. So you have build a path like this, and then you have finally build the index, so that this particular data is being copied from this. And now I'm trying to take this and try to print this and see what the information that it has. I'm not sure if it is holding any data or not, but ideally we'll see. Oh, good. So it has some data there. So now it should have some policy number along with the SSN number. Now you can see the policy number and SSN number, policy number and SSN number, that's been added, right? So this is how we build an AIX index. The AIX is nothing but it's a combination of two different primary keys. So in that case only we create an alternate index.